Neptune's south pole just warmed by roughly 20 degrees Fahrenheit in only 2 years, and nobody can fully explain why. Something strange is happening to the most distant planet in our solar system, and scientists are genuinely puzzled by it. I'm Arif Hassan, and this is AH History. Neptune wasn't found by accident through a telescope. It was predicted using pure mathematics before anyone ever laid eyes on it. In the early 1800s, astronomers noticed the orbit of Uranus kept drifting slightly away from where calculations said it should be. Two mathematicians, John Couch Adams in England and Urbain Le Verrier in France, independently suspected an undiscovered planet's gravity was tugging on Uranus. Le Verrier sent his calculations to the Berlin Observatory, and on September 23, 1846, German astronomer Johann Gottfried Galle pointed his telescope at the exact coordinates Le Verrier had calculated. There it was, a small bluish point of light, a genuine scientific sensation, a planet found through math alone. Despite that dramatic discovery, Neptune stayed a distant mystery for over a century, showing little more than a smooth, featureless disk through telescopes of the era. That changed in the summer of 1989, when NASA's Voyager 2 flew past Neptune as the last stop on its grand tour of the outer solar system. Just a few hours of close contact transformed our understanding of the planet, revealing massive storm systems, white methane clouds, and a storm called the Great Dark Spot, roughly the size of Earth, that later vanished entirely and has never reappeared in the same location since. Neptune's atmosphere is mostly hydrogen, helium, and methane, and it's that methane, absorbing red light and reflecting blue back out, that gives Neptune its striking color. But its weather is what really sets it apart. This planet hosts the fastest winds in our solar system, reaching roughly 1,200 miles per hour by some measurements, far beyond anything Earth produces. How is that possible on a planet sitting so far from the Sun, receiving so little external energy? That question still doesn't have a fully settled answer. Neptune radiates more than twice as much energy as it receives from the Sun, a strong hint that something hot and active is happening deep inside it. Its magnetic field adds another layer of mystery too, tilted roughly 47 degrees from its rotational axis and noticeably offset from the planet's center, a configuration we haven't seen on any other planet quite like this. Voyager 2 also revealed a surprisingly complex system of moons. The largest by far is Triton, and it's genuinely strange. It orbits Neptune backwards, opposite the planet's own rotation, a clear sign it didn't form alongside Neptune, but was captured later, likely a former resident of the Kuiper Belt, the same distant region Pluto calls home. Triton is also geologically active, with Voyager 2 spotting geysers of frozen nitrogen erupting several kilometers into its thin atmosphere, evidence of cryovolcanism, geological activity driven by frozen materials rather than molten rock. That makes Triton one of only a handful of confirmed geologically active bodies in the solar system, alongside Jupiter's Io and Saturn's Enceladus, remarkable given its surface temperature hovers around minus 235 degrees Celsius. Some researchers have proposed Triton could be hiding a subsurface ocean beneath its icy crust, similar to what's suspected on Europa or Enceladus, which would make it a genuine candidate in the search for life beyond Earth. Despite everything Voyager 2 revealed, no spacecraft has been back since. No orbiter, no lander, nothing. Neptune remains largely unexplored simply because getting there is extraordinarily difficult and expensive. Even Voyager 2, using gravitational assists from Jupiter and Saturn, took 12 years to arrive. Neptune belongs to a category called ice giants, along with Uranus, distinguishing both from the hydrogen and helium-dominated gas giants Jupiter and Saturn. Neptune contains a much larger proportion of heavier elements, particularly water, ammonia, and methane, which at these frigid temperatures exist in frozen or semi-frozen states, though under the planet's extreme internal pressures, they take on genuinely exotic states we don't encounter on Earth. Beneath the turbulent atmosphere lies a mantle of hot, dense material that may contain a bizarre form of water called superionic ice, where hydrogen ions move freely through a rigid lattice of oxygen atoms, functioning almost like an electrical conductor. Researchers suspect this layer may be responsible for Neptune's odd magnetic field, though that remains a working theory. Deeper still likely sits a rocky, metallic core under pressures millions of times greater than anything at Earth's surface, where what's actually happening remains genuinely speculative. This matters well beyond curiosity about Neptune itself. Over the past 2 decades, astronomers have found thousands of exoplanets, and a striking number fall into a size range similar to Uranus and Neptune, larger than Earth but smaller than Jupiter. This category appears to be extraordinarily common throughout the galaxy. Neptune isn't an outlier. It's a nearby, accessible example of one of the most common planet types in the universe. Neptune currently has 16 confirmed moons, and Triton alone accounts for more than 99% of the total mass orbiting the planet. Neptune also has a faint ring system, first suspected through stellar occultations and finally confirmed visually by Voyager 2, made mostly of dark dust and rocky debris. There are 5 main rings, the best known being the Adams and Leverrier rings, named after the 2 mathematicians whose calculations led to Neptune's discovery. Within the Adams ring, clumped, unusually bright segments called ring arcs, nicknamed Liberté, Égalité, and Fraternité after the ideals of the French Revolution, don't distribute the way orbital mechanics would normally predict. Researchers believe the small moon Galatea plays a gravitational role in holding them together, though the exact mechanism is still being studied. Neptune's rings appear notably younger and less stable than Saturn's, possibly only a few million years old, likely scattered debris from a shattered moon. In 2022, the James Webb Space Telescope turned its infrared instruments toward Neptune and captured the clearest images of its ring system in more than 3 decades, the sharpest views since Voyager 2's flyby. Because Webb observes in infrared, it can see through dust and gas that obscure fainter details from ground telescopes and even Hubble. Heidi Hamel, a Neptune specialist on the Webb team, noted it was the first time these faint rings had ever been observed in infrared light. In Webb's images, Neptune appears muted and gray rather than its familiar blue, since methane strongly absorbs infrared wavelengths. But the real value was structural detail, capturing 7 of Neptune's moons in the same image, alongside a faint band tied to global atmospheric circulation. And now to the genuinely confusing part. Neptune's southern hemisphere should currently be in its early summer season, meaning temperatures should be gradually rising. Instead, researchers found the opposite. A study analyzing 17 years of thermal infrared observations, led by Dr. Michael Roman at the University of Leicester and published in 2022, found Neptune's globally average stratospheric temperature dropped by roughly 8 degrees Celsius, about 14 degrees Fahrenheit, between 2003 and 2018. Dr. Roman said plainly that this was unexpected, since Neptune was being observed during its early southern summer, when temperatures should have been rising, not falling. What's actually driving it remains unclear, though researchers suspect it's connected to atmospheric chemistry. Methane absorbs sunlight and warms the atmosphere, while hydrocarbons like ethane and acetylene act as powerful infrared emitters that cool the stratosphere instead, and shifts in that balance can meaningfully change how much heat the planet radiates away. Similar chemical dynamics have been documented on Saturn. Neptune's massive, unpredictable storms may also play a role, and researchers have proposed the Sun's roughly 11-year solar activity cycle might contribute too, though that connection remains tentative. Then it reversed sharply. After 2018, Neptune's south pole warmed by roughly 11 degrees Celsius, about 20 degrees Fahrenheit, within just a couple of years, a swing that had never been observed on the planet before. Dr. Roman summarized it as pointing toward a genuinely complicated picture of Neptune's atmosphere, and part of what makes Neptune so fascinating right now is simply how little we still understand about it. Given how long it's been since Voyager 2's brief visit, several mission concepts are now in development to finally send something back. The most immediately plausible is Trident, a proposed NASA Discovery-class mission, a single focused flyby of Triton, rather than an orbiter, equipped with a high-resolution camera and a magnetometer to study its geysers, its magnetic field, and search for evidence of a hidden ocean. Depending on launch timing, it would take roughly 13 years to arrive, sometime in the 2030s or 2040s. A more ambitious concept, Neptune Odyssey, proposed by the Applied Physics Laboratory, would put an orbiter around Neptune for years of study, including a dedicated atmospheric probe descending directly into its stormy gas layers, the first direct measurements ever taken inside an ice giant. That mission, if approved, likely wouldn't launch before the early 2030s, with arrival not expected until the 2050s. There's even a genuinely inventive concept called the Triton Hopper, a mobile lander that would use Triton's own surface nitrogen ice as fuel, heating it to jet itself across the surface in a series of hops, rather than staying fixed in one spot. Still in an early experimental stage through NASA's Advanced Concepts program. None of these missions are approved and funded yet, but together they show a real growing appetite in the planetary science community to finally return to this distant, strange, still largely mysterious world. If you want to stay updated on whatever gets figured out about Neptune next, follow the channel, because there's clearly a lot more waiting to be discovered about this cold, blue, unpredictable planet.